I can do better than. Anyways, sometimes it was a little harsh. Let's go to page 29. I already covered a few things. I said that for the purposes of what we're doing and to make it easier, we're going to use reverse shading. Okay? We're going to use reverse shading, which means the area that is not shaded ends up being true for all inequalities involved. Okay? And so it's much easier to locate the solution region. So it's just a technique. It's not, a textbook would never do that. Okay? So that's just a technique we use to make our lives a little bit easier. Okay? This part here I kind of skipped over yesterday. This is important though. You need to be able to find the points of intersections, or you can call them corner points. It doesn't matter. It varies. And it is the points where the boundary lines meet surrounding this solution region. Okay? Points that are surrounding the solution region. That's basically what you're after here. So, given the fact that we're using reverse shading, if this is the solution here, if that's what you've labeled as your solution, then in this case there are 3 boundary lines. And so surrounding your solution region, you've got this, this, and this point, right? You've got 3 points that are surrounding the solution region. Okay? 3 corner points, 3 POIs in this case. So we would find them using our calculators. Okay? So basically, you'd enter this into Y1, Y2, Y3, and then find the intersections. Away you go. Good morning. Or should I say, well, well, well. There is this corner point here. So this is my solution region. So watch out for this scenario. In this case, there are only 2 boundary lines, correct? So this is my only one POI if you have this scenario. Some students tend to think that, oh, it's going to be the intercepts here maybe. Maybe these 2 are also corner points, and it's not true. Unless this were to be the boundary line, there's only 1 POI in this scenario. So you got to watch out. Sometimes there's 1, sometimes 2, sometimes 3. So you got to just look at the scenario there and go by that. So let's go to page 30 and put this to the test, right? Page 30, we already sketched it. Remember there's cleanup, intercepts, rewriting every time. And then we graph all of our inequalities at the same time using reverse shading. Write this down, reverse shade it. Okay? Just in case you're wondering, we used reverse shading. And how many points of intersections would this system have? Just 1. And it's hard to see. It's not the intercepts. It's this one right here. Okay? So that is the point of intersection. Let's label that. Can you type this into your calculator because it's good practice? So I'm going to show them. Well, they're actually right here. Okay? But I'm going to zoom up a little bit. So let's put this one into Y1. It doesn't really matter, but let's put this one into Y1, this one into Y2, and see what happens. Good practice to review how to use our calculators, right? So I'll show you how I enter it. If there is a fraction in front of my variable, I put that fraction in a bracket, like so. And then the next one is 2/3, right? So I go -2 divided by 3, close the bracket, x plus 3. Let's go ahead and see if the graph works for me. It's right there. I'm going to zoom standard this. I don't know how else to say it. Go back to a standard zoom, right? And there it is. So let's go find that intersection. Second trace 5. Enter, enter, enter. And there it is, 3.75, 0.5. It's hard to see on that screen. I don't know what happens to this camera sometimes. 3.75, 0.5. So let's write that down. I'm going to write it down right here. That is the point of intersection. We will, for this, just for our notes here, I'm going to also label it here. You don't need to do it twice. As long as I see it somewhere, you're fine. Okay? So there we go. 1 mark in this case. I usually give you half a mark per intersection, half a mark if it's easy to read. Sometimes you'll just be able to read it off of the graph. You'll already have it there. You'll see what I mean as we do more examples. And let's say I ask you something like this. Is 4, 5 a solution to the system? Is it a solution to the system? Show your work. You must enter, right? Must check every inequality, okay? You can't just plug it into one of the inequalities and be fine. You have to check every single inequality. Let's just do this by visual observation here. Where is 4, 5 located? 4, 5 is here, right? Is it a solution? No, it's not in this area, so it's not. We know that already. But sometimes I'll just give you like a bunch of inequalities, and I'll say, is this point part of the solution? And so you need to do it this way. You need to actually show the work algebraically. So I use the originals. I use this one. And so we plug in 4 and 5, right? So it's 4 times 4 greater than 6 times 5 plus 12. That ends up being 16 is greater than, this ends up being 42. And that is obviously false. You may stop at this point and just say, not a solution to the system. Okay? As soon as you get a false statement, you're done. I'm going to keep going because sometimes it'll be true, true. You'll keep going true until you find a false one. Or maybe they will all be true. So technically, therefore, not a solution. Just for the sake of our notes, so let's say you had picked this one first. 3y is less than or equal to negative 2x plus 9. Let's say you had picked this one first. Let's see what we get there. You have to watch out. It says what? 3y. Y is 5. So you have to make sure you substitute correctly. Negative 2 times 4 plus 9. This is 15. 15 is less than or equal to, this is negative 8 plus 9. It is just 1. This is also false. Okay. So definitely not a solution. It's definitely not. It's like false or both, right? I will make a note here. If a point is a solution, it must be true for all inequalities. Okay? Make sure you have a cloud around that and maybe highlight it. It must be true for all the inequalities. Otherwise, we would say it's not a solution to the system. Okay? Maybe I should do this, ask you this. Is the point of intersection a solution to the system without solving? It's right on both lines, right? This point is right on both lines. This one is solid, so it would be part of that one, but this one is dashed, right? And if a line is dashed, whatever is on the line is not a solution. So technically, even though we find it, in this case, it would not be a solution. Scratch, scratch. I hope not, but we'll continue this conversation. Okay. Keep going. Let's go to 31. I want to correct, and I also want to, I am not sure, I was thinking this morning, did I show you how to graph a vertical line on your calculator? Like a up and down vertical? I feel like I did, but this is the time where we review this. So let's say this is your system. This is inequality 1, inequality 2. This is going to be a diagonal line because you've got x and y. This is going to be a vertical line. Right? That's a special case. How about we do this one right away? We know that this is going to be a dashed line. We know that the true region is going to be where? Left or right? Less than left. Okay? And that means we're going to shade to the right, because if we're doing a system, we're going to shade to the right. This one, it's already cleaned up, so no cleanup needed. Just like your rooms this morning, right? They're cleaned up. When you come back, your parents are going to be super happy. Now we're going to find the intercepts. And you'll notice that these ones are very easy to do. When you just have x and y and a number, it's just going to be x is equal to 2, so 2, 0. Or y is equal to 2, 0, 2. Right? Because if y is turning into 0, it's just going to be x and 2. If x is turning into 0, it's just going to be y and 2. So it's going to be very quick to do one of these. Let's rewrite it. Y is greater than or equal to, the x comes over subtracting, and the 2 is already there. Okay, so then I tell myself that it's a solid line, true region. When it's y, it's only up and down. That's the only choice you have. Okay, and in this case, it's greater than, so it's going to be up, and I'm going to shade down. Okay, so this tells me where to shade in this case. So let's go ahead and do that. This one goes through, how about I make a note here, goes through 4, 0, okay, where x is equal to 4. So let's go ahead and graph it. I mean, if you did the homework, you already know how to do this. So let's bring this down. So let's do this one first. 2, 0, 0, 2. And we're assuming everything is 1. So I'm just going to... This is a solid line, so we're good. And then this is where x is equal to 4, and I'm just going to draw a vertical line. Label it. This is x is less than 4. This is y is greater than or equal to negative x plus 2. Shading. I got a shade below the diagonal. I got a shade to the right of this.
License plate ETG 956, blue Toyota RAV4, please. Go move your vehicle, you're in somebody's parking spot.
This is my solution region. I label it. And so far, so good. I'm just going to ask you to every time include your point of intersection. And that's where I'm going to remind you how to sketch, how to graph a vertical line on your calculator. So here it is. I'm going to say this. To graph This should probably be on your study sheet to graph vertical lines. We go y is equal to, and I looked this up on online, okay, so I don't know, I don't take credit for this, but it was pretty cool when I found it. You have to go 9 nines. You have to press 9 times, and then you just go at x plus or minus the number that you wanted to go through. And it's counterintuitive. Remember our quadratics unit? When we plug something into the bracket, it changes signs, right? So we will go y is equal to 999 x. Since it's positive 4 here, we're going to go the exact opposite. We're going to go minus 4. I'm going to use a red pen for this. Nice. And so that's how you can graph this vertical line. So let's type in this inequality, so this equation, this boundary line, and this boundary line into our calculator and see what happens. So it's negative x plus 2, and then it's 1, 2, 3, 1, 2, 3, 1, 2, 3, x minus 4. I hit graph. And see, there we go. You have your vertical line. So let's find that point of intersection. Second trace 5. Just hit enter 3 times. And it's 4, negative 2. So the point of intersection is 4, negative 2. Is negative 7, 20 a solution to the system? Negative 7, 20 is somewhere up here. So chances are it is. Right? So let's check. X plus y is greater than or equal to 2. I'm going to go negative 7 plus 20 is greater than or equal to 2. This would be 13 is greater than or equal to 2. This is true. Okay, keep checking. The other one was x is less than 4. So all we substitute is the x value. Substitute that in. Negative x is less than 4. This is also true. Okay, therefore, is a solution. And you're done. Let's go to 32. Thirty-two has one that at times throws students off a little bit. The yx one, or xy. So let's go to 32 and try that one. I think I'm not going to graph it. I'm just going to show you how to set it up, okay? And then you can graph it yourselves. So this one here is already cleaned up. If you want to find the x and the y-intercept, you can actually just do this. You don't have to write x-intercept, y-intercept anymore if you don't like to. X is equal to 6 here, 6, 0, right? Because you turn y into 0, so it's just x and 6. We're talking about the boundary line here. And then it's 2y is equal to 6, divide both by 2, y is equal to 3, 0, 3. There you have your intercepts. That's for you to graph, right? Then let's rewrite it. 2y is less than negative x plus 6. Divide both by 2. Y is negative 1/2 x plus 3. This would be dashed. True region is below. Reshade above. Okay. You should be able to do that one. Graphing wise, it's not too bad. But this one here, this one is tricky. I'm going to say that right off the, well, not really. After I show this to you, you'll be like, ah, whatever, I got it. But let's clean it up. It's technically not cleaned up the way we want it, right? So we'll bring the y over to the other side. So it's x minus y is less than 0. And remember, there's certain reasons why I make you do things to save you some grief later. If you want to do it a different way, be my guest. Like, as long as it's mathematically consistent, you can do whatever you want. And so if y is equal to 0, you end up with x is equal to 0. So it's just 0, 0. Okay? If you let x equal to 0, you end up with negative y is equal to 0. You divide both sides by negative 1. It's still 0. So here's a problem with this one. If you connect 0, 0 with 0, 0, do you have a line? You don't have a line. So you need to come up with a way to come up with another point. You need to find another point in this equation. So there's two options. Let's rewrite this thing. Negative y is less than negative x, right? We bring the x over to the other side. Oops. Okay, Hazel? Wake up. Okay. And then, where was I? Oh, yeah. And then we divide both sides by negative 1. Y is, what happens to the inequality when you divide by negative? To keep this true, we need to flip it, okay? What is the slope? Let me see here. What is the slope and the y-intercept of this boundary line? Slope is 1? Yeah. Can I say 1 over 1? And the y-intercept is 0, right? There's a 0 here hovering somewhere. Somewhere over there, it's like, hey, I'm here, but I'm not here, right? There's a 0 here. B is 0. So watch this. I use this to get another point. So I start at the y-intercept, I go over here, and then I use my slope of 1 over 1. You can do another one, 1 over 1. Oh, sorry. Thank you for letting me know. My camera work has a lot of improvement to do, right? There you go. Sorry, my bad. Let's do this again. I use this. Should we highlight this part? I use this to get me started. And then I use the slope, which is 1 over 1, to get me another point. I like to find at least one more to kind of make sure your line is in the right direction. And then you graph it. So you notice it's a 1-to-1 slope. Ooh, is it solid? Please, it's solid. Yeah, no, it's dashed. Sorry, guys. It's dashed, but it happens, right? So you just do this. No problem. Problem solved. And so this is your y is greater than x line. Let's make sure, I told you I wasn't going to graph it, right? But here I am graphing it. I lie all the time. Teachers tell you can't take the square root of a negative all the time, right? It's actually not true. We've been lying to you all this time, I know. Heartbreaker. 6, 0, and 0, 3. That's my the first line here, also dashed, right? That's this one. Y is less than negative half x plus 3. Okay? So you've got, that's how you graph one of those, yes? You like that, don't you? Perfect, thank you. So eventually, listen, eventually I would have probably figured it out, right? I should have. Why? What's the slope of this line, of this one I just graphed? It's negative, right? But it's going up from left to right, so that can't be. So thank you, Chandra. It's 0, 3, not 0, negative 3. So it's over here. Oh. Hold on. What's easier? I think it'll be a hard fix to change this. I'm just going to ask you to erase it. Thank you very much. This just makes my day, right? Hey, this is going to happen to you at some point when you do your work. It's going to happen to you. It's not, and hopefully you just say, oh, I'm just going to fix this, and I'm good to go. Okay? You know when else I should have caught it? When I'm about to find my point of intersection. You should realize, wait a minute, why are, on my screen I see this, but on my paper both are going up, like what's going on, right? So I hope there's many stops that you take where you ask yourself, you should always be troubleshooting. Okay, and now the shading. I got a shade above that one. And I got a shade, what about the other one here? It's a dashed line. The true region is above. I got a shade below. Okay, for this one I got a shade below. So it's here. So this is my solution region. The point of intersection, I'm just going to tell you what it is. Let's just write it down. It's 2, 2. Which actually, you can actually read this off the graph, but I would refrain from doing so because our graph isn't as accurate as our calculator, right? And I'm just going to leave it at that, okay? I'm going to tell you that this one is, it is, but check. How's that? You'd have to check every inequality that shows up, making sure it works. Okay, I'm going to stop here.